All right, welcome back, you cool cats and kittens. Carol Baskins is not here. For those of you who watch Tiger King, if not, don't bother. It's actually not that good. Got reeled in because of the media and everybody telling me that it was super good, and then it wasn't that good. So if you haven't watched it on Netflix, don't waste your time. There's better things to do. Seriously, you could just watch some paint dry or something. Because everybody in that thing is crazy. But today we're going to learn about lesson 118, which is going to be finding area of polygon using matrices. And so what this really is about is finding the determinant. So more than anything, more than the area in itself, I'm not really worried about whether or not you can find the area, because you could, but the important part is the determinant. I'm sorry, I blanked out because I just realized I didn't level my tripod. Oh, I blame Lydia. All right, so let's get into the lesson. Okay, so before I even get into the example, it's here. I wrote it here because I want to do this first and then maybe go right into here. So the first thing that I have to do is understand. I want you to understand what this is. And the determinant is a little bit tricky to find. That's why I'm going to try something new. I'm going to try to use blue and red. But I know that in this board and with the glare, sometimes the blue and the red can't be seen as well as the black. That's why I've been teaching all my classes with black. Let's go back a little bit about matrices, and hopefully you understand. So we have 3 rows, we have 2 columns. This is a 3x2 matrix, matrix B, because in example 1 we have matrix A, not because of anything else. So this one is A, B, C, D, E, F, right? Pretty easy, just letters. And so what is the determinant? The determinant is going to be found by doing the following, okay? And the determinant is like an indicator of what the matrix will be like. And we use it for other things, but I can't tell you that because that's algebra too. And so what we're going to do is, for the determinant, we're going to add. That's why we have the blue one for add. Oh, I told you, this blue is probably not going to be seen. Let me just check. It's not that bad. And the red one is to subtract. Oh, terrible. They're brand new markers too. Oh, you can barely tell because of the glare. Let's move around that glare monster. Yeah, let me try to get a better red. Hopefully I have more. If not, I would have to do it green. Let's see what works better. So this one sucks. Let's see this one. Same thing. Is it the marker? I think it's the board. No, the marker's not very good either. Am I having like bad memory or something? Because I thought these ones were better than just that. Oh, terrible. I might have to do green. Let's see green here. Oh, even worse. What is going on? These markers suck. Anyway, I'm going to do red then. So you're supposed to add the blue parts, and you're supposed to subtract the blue part, the red part. So it's going to be, hang on with me because it's a little bit complicated. I'm not going to lie. It is a little bit complicated. This is one of the reasons I have to do it. So first thing is that we're going to multiply A times D. We're going to multiply C and F, and we're going to multiply E and B. And we're going to add those together. So my first one will be my determinant would be A times D plus, okay, so I have to do it like diagonally like this, okay, going downwards, okay, A times D times C times F plus, and this is where it gets a little bit tricky because we know that E can't go with anything down here, but B was left up here. So we kind of went from E all the way to B. So E and B are going to be multiplied together. Okay, so that's the stuff that we have to add up. You add A, D, C, F, and E, B. Okay, then this is where we start to subtract. What are we going to subtract? Well, we don't need the blue one anymore. What we're going to subtract is the opposite. Now we're going to go B, C, D, E, F, A. This is why I'm telling you, it's a little bit complicated. Yeah, it's not like the best way to do things, but that's how it's done. You have to learn how to do it. And so we have to go BC minus BC. And by the way the book puts it, I don't like it. To me, it makes it confusing. So it's BC, then DE minus DE. That looks like an C, so I'm going to make it more like an E. There we go, DE minus FA. Let me check the glare once I write this down, because you know that glare. Yay! You can actually tell. So the determinant would be AD plus CF plus EB minus BC minus DE minus FA. Literally, this is how you find the determinant. So that's how you find it. That's why we go to example 1 to be able to find it. And so I'm going to do the same thing with the red and the blue because I think it's helpful. So we're going to multiply 6 times 2, 9 times 1, and 3 times 1. And we're going to add it together. So I'm not going to do the second part first. I'm going to do this multiplying and adding part first. So determinant is 6 times 2 plus 9 times 1 plus 3 times 1. All right. Sorry about that. My board has scratches there. So that's the first part. And then the second part, we have to do 1 times 9, 2 times 3, 1 times 6. So it'd be minus 1 times 9 minus 2 times 3 and finally minus, and I know I ran out of board because obviously this board is super long, 1 times 6. Okay, let me check if you can see what I wrote. Yeah, you can. Good job. So now what we're going to do is do that. 6 times 2 is 12. I'm not going to be switching markers anymore. Plus 9 times 1 is 9. Plus 3 times 1 is 3. Minus 1 times 9 is 9. 2 times 3 is 6. And 6. So we have 12 plus 9 plus 3. 12 plus 9 is 21 plus 3 is 24. Minus 6 times 6 is 12. 6 plus 6 is 12. Plus 9 is 21. My determinant then becomes 3. Oh no, I got it right. Oh, by the way, you have to put determinant of matrix A is 3. So hopefully you understood all of this. I did what it means, and I did the first example. So now we can move into finding the area, which is actually just 1/2 of the determinant of a matrix. What type of matrix? The matrix of the polygon that you're doing. So if you remember, we can do polygon matrices by putting XY in a specific type of arrangement. All right, so yeah, let's move on into that. Hopefully, any questions? like you can. All right, so in the second example, we have a polygon, right? I think it's a pentagon, irregular pentagon. And then they give us this are the coordinates. By the way, you always have to put the coordinates in either clockwise or counterclockwise order. If not, you're going to get it wrong. So that's how we did it. They did clockwise, and they started by 0, 2, and then they just went all the way around. Okay, so these are the coordinates, but they did a terrible job because they didn't even show you what the matrix was that they used. All right, so the matrix that you're supposed to use is this. It's going to be 0, 2, 0, 2, 1, 1, 1, negative 2, negative 2, 0, and negative 3, 2. That's the matrix that you're supposed to use. Then you're supposed to find the determinant, and then you're going to find half the determinant, and that would be how you find the area. Because literally, the area would be 1/2 of the determinant of that matrix. That's how you find the area. That would be the area equals 1/2 of the determinant of this matrix. So, what is the determinant? The determinant is going to be 0 times 1, which is 0, plus, I'm going to do it a little bit quicker than before. Hopefully you guys understand how to do it by now. It's not very hard. It's just you needed to kind of see it first. 0 times 1, 1 times negative 2, which is negative 2. So still let's put plus negative 2. 1 times 0 is plus 0. Plus 0. Negative 2 times 2 is plus negative 2. And negative 3 times 2 is plus negative 6. All right. Then we're supposed to do 2 times 1 minus 2 minus 1 times 1 is 1 minus negative 2 times negative 2 is positive 4 plus positive 4. 0 times negative 3 is minus 0 minus, finally, 2 times 0 is 0. Yay, look at that. We have 4 zeros, so we don't really have to worry about that. So in here, we're going to get negative, we're going to get negative, we're going to get negative, and we're going to get negative. Everything is negative. Yay, you're not really adding anything positive. So it's going to be negative 2, minus 2, minus 6, minus 2, minus 1, minus 4. I got rid of the zeros, okay? You don't really need the zero. So negative 2 and negative 2 is going to be negative 4, negative 10, negative 12, negative 13, negative 17. Okay? That would be my determinant. Half of my determinant then would be 8.5, negative 8.5. Look at that. Oh, they got 19. I got 18. Huh. Oh, I got 17. Hey, wait, what? I'm off by 2 because it's 9.5 square units. Obviously, because area can't be negative, it won't be negative. Let me see where I did it wrong. So 0 times 1, 0, 1. 1 times 2, negative 2. 1 times 0, 0. 2 times 2 is 4. Dang it. Negative 4. Yeah, they're right. I just made a dumb mistake here. Divided by 2, negative 9.5. Everybody makes mistakes, right, Lydia? And then we have 9.5 being the answer. 9.5 units squared. Yep, units squared. Boom. So more than anything, you just need to know how to do the determinant, which isn't very hard. Just like anything with matrices, it's not super hard. You just need to know how to do it. And I had to show you how to that is. Okay, so this is the last lesson I will teach you for geometry. Hopefully you had a great time. Yay! Who needs Tiger King when you can just watch these videos all the time? Yay! And so that's it for our journey for geometry. Hope you liked it. And yeah, 2 more tests and we're done.